Okay, so these are 4 students. I'm just going to give them some names. We can call this Phoebix, Morgan, I don't know, Canada, and let's call this Rachel. There you go. And what I want to do is I want to sort them out in size order from smallest person to largest person. At the moment you can see they're quite not that way. So we're going to create an algorithm. That means code, a sequence of code in order to do that. And what we want to do is, to begin with, we want to check Phoebix against Morgan. Is Phoebix bigger than Morgan? No, Phoebix is not bigger than Morgan, so we're going to leave Phoebix where he is, and we're going to leave Morgan where he is. We're now going to check Morgan against Canada. Is Morgan bigger than Canada? Yes, he is. So what I'm going to do is I'm going to put Canada here, Morgan here, and now we're going to check again, but this time we're going to check Morgan against Rachel. Is Morgan bigger than Rachel? No, he's not. So we've got nowhere else to go. We've checked. So Rachel doesn't need to check against anybody else because there's nobody there. So we're done. Well, are we? No, we've just done one full cycle. We've just checked it from Phoebix all the way to Rachel once. But we're not in the perfect order. So what we're going to do is we're going to now do another full cycle. So let's do it. Is Phoebix bigger than Morgan? Yes, Phoebix is bigger than, so not Morgan, sorry, my bad. Canada. Yes, he is. So we're going to switch. Canada is going to go there. Phoebix is going to go there. Is Phoebix bigger than Morgan? No, he's not. Is Morgan bigger than Rachel? No, he's not. So we've now checked this twice. But we're going to keep checking until we've done every combination. So we've now done it twice. I would like us to check it a third time. So we go again. Nope, no swap. No swap needed. No swap needed. So we've checked it now 3 times. We've done 3 cycles of this. There's no need to go again because we'll be on our 4th time. And we've only got 4 people in here. So if we've got it right there, and correct there, there's no need to check it a 4th time. Because if we write the 3rd time and there's no swaps, so once we checked it the 3rd time, so we check it once, we check it twice, we check it 3 times, we're going to have it in order. We call this a bubble sort. In fact, it's an inefficient bubble sort. That means it's not done the best way, but it's still called a bubble sort. So what we're going to do is we're going to put this into code. If you think you can give this a go yourself first, great, try it. Otherwise, stick around. So in Python, I'm going to make an array. I'm going to call it size. I'm going to not put people's names in it, but I'm going to put numbers in it instead. So we've got Phoenix, which is, let's say he's size 10. We've got Morgan, size 13. We've got Canada, which is size 4. And we've got Rachel, which is size 15. So basically, we've got 10, 13, 4, and 15. And what we want to do is we want to do a cycle through. To do a cycle through, we talk about a loop. So we want to loop through this array. So we want to start from here and get to here. So I'm going to do a for loop for I in range, and we're going to get the length of size. Fine. I also, though, want to keep repeating this over and over and over again. So what this is going to do, this for I in range, what we've got here, is it's going to basically check this person against this person, then this person against this person, and this person against this person. But if we left it as it is, it's only going to do it once. So look, if I was to do print and we do size I, just to show you what's going to happen inside, and I just make this a bit bigger, it's going to loop the numbers once. So that basically means it's only going to do the checking and the swapping once. We want to keep doing it over and over and over and over again, just in case we need to make more swaps. So if you remember, if we go right back to the beginning of this bubble sort, the way we want this to work is we want this person to check against this person. Does there need to be a swap? No. So we leave Phoenix there. We then check 13 against 4. Does there need to be a swap? Yes. So that's what we're going to do now. We're going to then swap this person and this person. So swap the numbers 13. Let's just do this quickly. And 4. That's 4, sorry. And this is 13. And then we want to check this person against this person. Does there need to be a swap? No. So we've done one cycle. We've checked it once. But are we done? No. We need to check it again. The way we've got our code at the moment, it only does it one time only. So we want to keep doing it. So I'm going to make a for loop within here. So I'm going to do a for, and I'm going to change this from I to outer. We call this an outer loop. Inner. It doesn't make a difference if I call it IX. I could call this X, I can call this null. I'm going to call it inner because I know what we're dealing with. In range, length, size. I swear to God, these guys are loud with their stupid lawnmower thing. 1 minute, I'm going to pause the video. I'm then going to just do print size inner. So we're not doing any swapping at the moment. I'm not saying I want to swap this person with this person. I'm just showing you that it's going to now display things. So we've got one cycle. It then does it again. It does it again. It does it again. Does it again. Happy days. But we're not done. I want code which will check this person against this person to see who's bigger. What can we use in code to say, is this person bigger than this person? If you want to give it a go yourself first, pause the video. Well, you would use an if. So if size inner. So we're starting. Let's put positions on there as well. This is position 0, this is position 1, position 2, position 3. Is this, so the person in 0, bigger than the person in the 1 next door? So what I'm going to do is I'm going to say greater than size inner plus 1. So again, we're saying, is this person bigger than this person? Yes, they are. In my little scenario here. So if they are bigger, I want to swap this person to go here and this person to go here. So now we've made a swap. But look what happens when we make the swap. I'm going to put this person, I want them to go here. But now we've lost Canada. Canada is gone. That is an issue. What solution, so forget coding for a minute, what solution do you think we could do so that we don't simply lose somebody on the swap? Okay, I'm hoping you've given it a go, you pause the video, you've thought about it. What I'm going to do is, I'm simply going to put this person down here. I'm then going to put this person here. I'm then going to put this person here so we don't lose the swap. So I'm going to show you that in program code now. I'm going to put, if it's bigger, I'm going to put this person in what we call a temporary variable. So I'm going to make a variable, I'm going to call it temp. So look, if this number is bigger than this number, we're going to do make a variable called temp and equal it size inner. I'm going to pause because the loud people are back. Okay, so we'll put that person into temp. They're in inner, we're going to put them into temp, so that we don't lose them. And what we're going to do now, if you can have a look, is that this person and this position need to switch. So we're now going to put whoever's in inner +1, so size inner becomes size inner +1. Remember, inner keeps track of where we're at. We're in position 0, it's going to put whatever's in position 1 into position 0. So let me just move this out of the way so you can see it clearly. So again, we want to put this person into the one next door. So we put it into temp. That's what this bit does. It checks to see if it's bigger. When it is bigger, we're going to put it into temp. We're then going to put the one in size inner +1, which is next door, into position inner. But now what do we want to do? Well, we want to put this guy in temp into inner +1, so we've got a swap. This is really simple to do. Size inner +1 equals temp. So let me just move this bit out of the way. We're going to put this guy into position 1. So we've made our swap. Let me just clean this up a little bit more. So currently we're here, we're on position 0. Our inner in our for loop is on 0. We're going to check it against inner +1. When we've done that, we move inner and inner goes up by 1. So we're now going to check this person against Morgan. Is Phoenix bigger than Morgan? That's what this bit does. Phoenix is not bigger than Morgan. So we don't need to do any of the code, and we just simply, the loop goes up by 1. The for loop goes up by 1. We then check Morgan against Rachel. Is Morgan bigger than Rachel? Nope. So we simply, inner goes up by 1 because it's in a for loop. We don't do any of the if statements. Now we're going to come into a little bit of a problem. We're going to check Rachel against who? There's no one there. This is what's going to happen if we try and do that though. So let me just clear the code. So where's the delete button? There you go. Run it. And you'll notice it says index out of range. That's because of the following. It's trying to check the last person, which is Rachel, in position 3. So we're looping 3 times because it's, well, 4 times should I say, because we're looping the size of the list. And we are checking it against inner +1. This does not work. Really what we want to do is stop when we get to the one before the end, which would be at Morgan. We don't need to check Rachel against anybody else. We just stop here at Morgan. So we do want to loop the length of the list, but not the whole length of the list. We always want to stop one before the end. So look what I'm going to add to the code. I'm simply going to add to the code -1. What that basically means is that we're going to loop 4 times, but actually we're going to loop 3 times. We're going to stop one before the end. That is then going to stop us from having to check the last person against nobody, which causes it to crash. So by doing this, everything works fine. So it's going to stop now on Morgan by us, and at -1. So if I hit run, it's not crashed anymore. You don't see any results because I'm not displaying anything, but it hasn't crashed. Okay, let's just again clean this through, and let's show this using size now, our numbers. So I'm going to do 10, 13, 4, and 15. Let's trace this through. I'm going to show you what the end goal will look like. So let's do a before and after. So it's print size beginning, before we sorted it out into order. Print size end, after. If I hit run, this is a before and after. Before we sorted it in order versus now it's all in order. Look at that. Beautiful. So let's trace this through so you get comfortable with how this works. So we've got outer. Outer, it starts on 0. We've then got inner. Inner starts on 0. So on the first time we loop, which is outer is 0, we're going to then go to the inner loop. So our array is called size. If size inner is greater than size inner plus 1, which in this case it's not. So we're not going to do any of that if statement. The for loop will go up by 1, the inner one. Remember, the inner goes up all the way to the end first. So now we're checking 13 against 4. So inner against inner plus 1. Is 13 bigger than 4? Yes, it is. We can see quite clearly. So what do we do? Well, step 1, because it is greater, we do line 7. Line 7 is put whatever's in inner, which is 13 at the moment, and put it into temp. We're then going to, line 8, put whatever's in, so I'm just copying line 7 by mistake there. Line 8, put whatever's in inner plus 1 into inner. So we switch, well, we copy the value. So now we've got 2 4s. That's not ideal. So the final step we need to do, which is line 9, we put temp into size inner plus 1. So inner is 1 plus 1 is 2, so we put it into its next door neighbor. So 13 will now go there. Happy days. We then go again. Inner goes up by 1. Let me just clear this out. So inner now is going to be 2. We do our checking. Is 13 bigger than 15? No, it's not. So no swap. So we're done with the inner loop, which has gone through every combination there. We then go back to the outer loop because we're not in the perfect order. The outer loop is going to go up in a second by 1. Remember, we stop at 13 because of the size minus 1. I forgot to mention that. So we don't go any further in our inner loop. So we stop there so we don't crash it because 15 can't check against anything. And now what we're going to do is we're going to go back to the outer loop. The outer loop goes up by 1. Inner loop starts on 0 again. So we're now going to check if size inner, which is 10, is it bigger than inner plus 1, which is 4? Yes or no? Obviously, it's going to be yes. So what are we going to do with that? Well, we put 10 into temp. We put the 4 into inner. And then we put the temp, whatever value's in there, which is 10. And we put that into inner plus 1. Inner goes up by 1. So now we're checking position 1 in the array, which is 10. against position inner plus 1, which is actually 2. So 13. 10 versus 13. Does there need to be a swap? No, it doesn't. So inner goes up by 1 again. So inner. I'm going to just hold it there for a second. So we've done our iteration, so we checked 13 against 15, doesn't need to, and we're stopped. So outer goes up by 1, we go through the whole situation again. There doesn't need to be a swap anymore. So have you noticed that we actually got it in order? But because outer is going to go the length of the array, that means 4 times, it's still going to keep going. It's just going to keep going and going and going, even if we've got it in order. That is why it's inefficient. It's inefficient because once we've got it in order, the outer loop will still go the length of the array. In another video, I show you how to do it a little bit more efficiently, but what we can do is add -1 to this as well, to outer. And the reason being is, and you can see the results the same, we don't need to ever loop 4 times on the outer loop. It doesn't need to be done. Once we, on the outer loop the 3rd time out of this 4 numbers, the array will be in order anyway. Mathematically, you can work that one out yourself. So what we have here is the finished inefficient bubble sort. You've got outer, which is length of size -1, inner, length of size -1. You then do your comparison. Is inner bigger than inner plus 1? You then swap it, etc. Let's try this though with names. I'm going to show you why it's inefficient for our basic bubble sort we've got now. So we've got Adam. We've got Ben. And we've got Cohen. These are our 3 names. They're already in order. Adam isn't bigger than Ben because A is not bigger than B. That's how it works. It looks at the letters. A is not bigger than B, so no swap. B is not bigger than C. No swap. It's already in order. But because we're using our for loops, it doesn't know that we need to stop. So the outer loop does it again. The inner loop does its job, it checks, there's no swaps. And it keeps going until we get to the end. Obviously the outer loop isn't going to get to 3 because we've got the -1. But my point being is, that's inefficient. So this is one way of doing a bubble sort. To clarify, you put it into temp. Let me just, so reminder, we check the inner, is it greater than the inner plus 1? If it is, we put inner into temp. We then put the inner plus 1 into inner, and then we put the temp into inner plus 1. You need to remember I've got 2 loops, 1 loop to go outer to make sure we've got every combination, and inner to check each number within there. Remember the -1 as well. This is the same code every time. It doesn't matter how many numbers you've got in an array. You can have loads and loads and loads. You can have thousands of numbers. This would be the same code every single time. The algorithm is the same for this bubble sort. Yes, it's inefficient, but it's the same. If we wanted to do it so that we are looking at, let's sort the list out, largest to smallest. Pause the video. What change would you make if you're doing largest to smallest? Okay, what you'll do is you'll just simply change that symbol to less than. So if size inner is less than size inner plus 1, so it's 10 smaller than 13. Yes, it is, so switch. So we're going the other way this time. Is 10 smaller than 4? No, it's not, so keep 10 there. Is 4 smaller than 15? Yes, it is. So we put 15 there and we switch it with 4. So we're doing it in descending order this time. All we did was change that symbol from greater than to less than. So now you know how to do it in both directions. Ascending order or descending order. If I said put it largest to smallest to largest, you make it greater than. And there you go.